Hit record here. All right, so welcome today to Ansible and networking. Again, just a couple of quick housekeeping things. We are going to be recording this session, and we'll be happy to send a link out to all the registrants and attendees after the fact. We've also muted your lines, but you can still interact. So to ask a question, use the little ask a question section in your GoToWebinar control pane on the right. Also, wanted to take a brief moment to introduce our speakers. My name is Justin Emmers. I'm the product owner here at Ansible by Red Hat. And we're also joined by Peter Spragata. Peter is in charge of all things network and network automation here at Ansible by Red Hat as well. So given that, we'll just go ahead and dive right into this. All right, so we are, sorry, little slide clicky problems. We are Ansible, and fundamentally, our goal really is automation for everyone. So what we wanted to do in the brief slide description here, we are going to go into a demo, and I think that's going to be the part that most people will find eminently interesting and awesome. But as Ansible as a whole is kind of new to this whole networking genre, we thought it would be a good idea just to kind of introduce Ansible and talk a bit more about Ansible and what Ansible is and what we do. Fundamentally, we are automation for everyone. And what's interesting, I think, particularly applicable to the network space, is that IT really is a group of loosely coupled fiefdoms. You have your networking teams, your database teams, your storage teams, your operating system teams, your security teams, and so forth and so forth. And the challenge with most automation platforms is that they've tended to focus on just one of these teams. And the problem with that is ultimately that communication issues still abound between these different teams and different channels. But additionally, it becomes very hard to help other people with automation of their stuff. I mean, if you think about it, like the worst thing that could happen to you as an employee is someone else comes in and says, hey, we're going to automate what you do. And you effectively lose all control of that, and you lose the ability to really add additional value. So what we really seek to do here at Ansible, and what we believe that we're very successful at, is providing a broadly applicable automation platform in Ansible that allows organizations to more effectively automate, because all the different teams can begin to automate the things that they're doing individually, which means they get to retain control, which means they then get to spend more time focusing on more interesting problems. And we're going to talk a bit more about kind of what that means and what it looks like in a second. So first, let's talk a bit about complexity. We've all seen wiring closets like this. They're scary. The reality is that complexity in IT is only getting worse. And with complexity, you have a whole host of issues that are arising due to this complexity. First and foremost, complex environments are more challenging and more costly to build. They're more costly to maintain. They're not very repeatable. They take longer to fix when they break. And in fact, keeping them up in the first place is a significant challenge. It takes very specialized and often extraordinarily expensive resources to maintain, build, and develop complex environments. And it's increasingly difficult to accept new technologies into complex environments. But the biggest thing about all of this is that even the simplest of tasks in a very complex IT environment often end up taking extraordinarily long periods of time to effectively complete, because there are so many interdependencies and challenges related to the complexity in the environment that everything just takes longer. And as a result, it's harder to get things done, it's harder to innovate, it's harder to move your organization forward, and ultimately the entire organization and often the business suffers as a result of that. So what we propose is that when you automate, you're actually able to accelerate. So this is really what Ansible does. Ansible, by automating the kind of drudge work that you normally are tasked with doing, allows you to focus on the more interesting problems in your organization that both give you more job satisfaction, but also provide a significant amount of innovative capability and just value to the organizations that you're working in. So when you're able to automate all of those things away and automate the manual processes that you're currently going through today, you have better repeatability, you have better sustainability and maintainability of these things that you're actually maintaining. But the biggest thing that does is it creates the one thing that you can never get enough of in an organization, and that's time. So what is Ansible? Well, Ansible is several things, but the underlying automation engine itself is simple, powerful, and agentless. So simple is great. Simple means that everyone can be expected to learn it and use it to automate the things that they're doing today. Simple is cool because it means that the time to start using this and do real work with Ansible is very, very short. You don't need any special coding skills. You don't need to be a developer. And it's just as applicable for developers as it is for sysadmins, as network admins, and so forth. Everyone within the IT organization can easily read, understand, and begin to use Ansible today. So simple is great, but if it's not extraordinarily powerful, then that gets you nothing. And I think what's interesting about the power component that you'll hear us talk a lot about today is that with the underlying Ansible automation engine, we've built a model that allows for significant flexibility in the overall platform. And we'll talk a little bit about the Ansible architecture and how we bring that power to bear. But fundamentally, with the underlying platform that can do everything from app deployment to config management to workflow orchestration, and ultimately perfectly describe your entire application environment from the network and storage all the way up to the last level layer 7 network device that your traffic flows through, can all be perfectly described with Ansible. And then finally, we bring all of that power to bear in an agentless fashion. Which of course is perfectly applicable to the network space because you're not installing network or agents on your network devices. But it also allows us to piggyback on top of the existing management frameworks that you're already using today and that you've already gotten approved through firewall policies and security policies like OpenSSH and WinRM on the Windows side. So what's neat about this, of course, is the same stuff that your sysadmins and developers are able to use to describe and manage their processes is the same thing that you're able to use today to manage your networks. Now, what is Ansible? Great, it's simple, it's powerful, it's agentless, but that really didn't answer your question, right? Well, Ansible is a simple automation language that, again, can perfectly describe this entire application and IT infrastructure in playbooks. So it's both the language as well as the underlying automation engine that interprets or runs those particular playbooks. And then finally, we have the thing that we sell is this thing called Tower. Tower is the enterprise framework that allows you to more effectively control, gain knowledge from, and delegate access to the various jobs in your environment through both the UI and RESTful API. Okay, brief description of how Ansible works here. So the couple of things I'm going to focus on, the users. I mean, they are both what drive forward and make the entire IT environment possible, but ultimately users and admins are the ones that are writing playbooks. And then playbooks are run through the automation engine against a inventory, and an inventory is just a collection of endpoints that you're managing. Inventories could be servers, they could be bare metal, virtual, they could be cloud devices, they could be network hosts or network devices, firewalls, routers, switches, containers. It doesn't really matter as long as it's something that you can communicate to via an API or via SSH or WinRM. It's something that can be encompassed in an inventory and managed with Ansible or automated with Ansible. Then the next thing I'd like to call out are the modules. So we're going to be talking a lot about modules today, and the modules for networking are really what make our networking capability possible. We haven't made any significant changes to the underlying Ansible automation engine. What we've done is extended the capability of the platform by adding modules, and that's a big piece of how we generate a lot of value and a lot of power of the overall platform is just by adding modules to talk to more things. Today, we ship with well over 450 different modules, not including all of the new networking ones that Peter is going to be talking about today. But ultimately, there's a good chance that pretty much everything that you're running in your enterprise shop has existing modules, roles, and playbooks to manage them and automate them today. So when we talk about how Tower fits into this whole picture, we won't make this a huge Tower stump speech, but if you're using any kind of Ansible within your organization, we would definitely encourage you to take a look at Tower. Tower enables you to centrally control how you're running Ansible within your environment and enables you to do things like job scheduling to ensure that you're applying, say, common security baselines across your entire environment. Furthermore, it allows you to gain a significant amount of knowledge of how things are being automated and what's actually happening in the environment. And that includes things like Active Directory and LDAP integration and full audit trails of the jobs that folks are actually running. And then delegation. So role-based access control allows you to create self-service profiles to ensure that certain users in your environment have access only to the automations that they're supposed to and only in the environments that they're supposed to have access to. So we could go into a little bit of detail about Tower. I'll leave you guys to read the slide after the fact, but fundamentally it's a lot more than just a UI. We can do push button access, and then again centrally log and allow you to capture all this information for compliance purposes after the fact. And then the big question ends up being great. So we've been extraordinarily successful as an open source project in a company that was ultimately acquired by Red Hat in kind of the systems management, DevOps, and development space. But the big question is, well, really, why network and why now? And there's a lot of schools of thought of this, but fundamentally, when you start to look at it, for a great time now, the network teams have been very good at doing things that have been particularly specific to their view of the world, but in a manner that doesn't necessarily play well with what the rest of the IT organization is doing. And this came out in an SDX cloud management report where people were basically asked the question, like, which, in terms of your cloud migrations and your cloud efforts, where was the area that you saw the least maturity? And the overwhelming response here was the network. So a lot of folks looked and they said, the storage and the compute and the operating systems and even the development tools were all very well understood, but the networking component stuck out as a really big kind of sore spot and a spot that needed a lot of improvement. So that's ultimately why we hired Peter. Peter has really done a great job of really bringing us into the network world and helping us understand the unique challenges that are representative of the things that networking teams are struggling with. But then, of course, we were able to work with him and really help define that Ansible is the tool that now entire IT organizations can use to both properly and perfectly communicate what it is that they're doing, but also give other teams and users the ability to replicate what it is they need to be done in their own particular environments as they move forward. So that's all I've got at this point. I'm going to go ahead and hand it over to Peter, and we'll continue on.
Great, thanks, Justin. And certainly thanks to everyone out there for taking time out of your busy days, your busy schedules to join us today. So as Justin said, my name is Peter Spragata. I'm principal engineer here at Ansible, now a Red Hat company. And what I'm going to do is spend some time, talking a little bit about our approach to creating, the right set of hooks and/or integration points within Ansible to really tackle networking problems. So I'll share with you a little bit of the thought and theory behind it, why we've done what we've done, but we'll try not to spend too much time on slides. Much like many of you out there, I am an engineer by trade and even more so by heart. So we'll get off slides. We'll actually get on and we'll actually look at some of this, some of these modules in action and show you some of the things that we're doing, and kind of take that approach with it. But I think, before we really get into it, I think there's a really key point that Justin alluded to that I want to kind of reemphasize here a little bit more. Ansible has been, tremendously successful in the systems and application development world in terms of being able to automate, building out systems, building out application environments, creating continuous integration, continuous development pipelines. And we really want to carry a lot of that success over to the networking space. And as we looked at the move into the networking space, it was very important that we didn't just simply take what was a successful tool in the systems world, try and kind of repackage it, reformulate it, and just kind of lob it over the wall at the network teams and say, here you go automate your network. Because I think that we would all agree that that's a recipe for failure very quickly. So we wanted to take some time and really look at this from the context of networking. And I'm a perfect example of that. I bring a 20+ year career in the networking business. I do exactly what many of you out there do today. I was a network engineer, network operations. I've run engineering and operations teams. So, I'm intimately familiar in the context of networking with a lot of the operational challenges that we're faced with in trying to automate today's massively scalable, heterogeneous network environments. As of 2 weeks ago, we introduced Ansible 2.0 Network Technology Preview, and I cannot stress enough that this is very much step one on a very long journey. We're really excited about this. It's really the culmination of really the first sets of integration points that's going to allow Ansible to start to automate network devices. So for those of you who have been a part of the Ansible community and a part of the Ansible family, you know that we undertook an effort over the last year or so to write Ansible 2.0, which was almost a complete rewrite from the 1.9 code base. We released 2.0 early in January after a significant amount of testing and code development and integration. And we decided that that was the right platform to introduce our networking support. So we wanted to get the networking modules in a state that they were stable and that folks could start to play with them. As many of us know, right, networking teams tend to be much more conservative in their adoption of tools and in their use of tools and ultimately automating what has traditionally been very manual processes. So we provided the network technology preview so that you could get your hands started on it, playing with it, start utilizing it, and start working with it in your own labs and in your own environments, prior to the final GA release, which is currently slated for the late April timeframe as part of Ansible 2.1. But as we put this together, there was kind of two key points that I was absolutely adamant about, within the engineering community in terms of what we had to do to be very much successful. First and foremost is that playbook authoring had to remain simple. Ansible is built on a tenet of simplicity, and that simplicity had to carry through for everything we do. What that means in the context of networking is not only did the modules have to be easy to use, but they really had to be modules that were used like every other module in the Ansible ecosystem. It could not be a case of, okay, in order to do networking, all of a sudden we have to put Ansible in some kind of special operating mode. We had to develop playbooks a special way. We had to do all of these, jump through hoops and dot these I's and cross these T's to ultimately finagle Ansible to work with networking. And that was not going to be, that was not the way we wanted to build the integration. So playbook authoring with networking modules is the same as it's always been. And so there's no change there. The second area that was absolutely adamant, that we were adamant about, is that module development had to be the same. It couldn't be a scenario whereby you had to learn a whole new way to write modules to ultimately build and extend upon the integrations for networking to ultimately introduce new feature functionality into the Ansible community. So module development stays absolutely the same moving forward. I like to talk about this, though, a lot from the concept of, from mop to playbook. And for those of you out there that remember the old telco days, which is certainly where I came from, we all remember writing method of procedure documents, right? And these were these massive documents that numbered in the hundreds of pages that effectively documented what a change was going to be to the network. And it talked about everything from config changes to show commands to what we were going to evaluate to how we were going to roll it back to how applications were going to be tested and whatnot. So with Ansible, how we kind of subscribed to this is we wanted to take that concept of what the mop was and transform it into what a playbook is. Because in reality, what we know, and as I was out meeting with so many of you out in the community, we heard the message loud and clear in that networks today are still predominantly run by copy and pasting config commands out of a notepad and into a terminal window. And then we all cross our fingers and hope that the guy doing the copy and pasting or the gal doing the copy and pasting doesn't accidentally paste it into the wrong terminal window. So, we really wanted to try and solve at least that problem to get started with. In addition to that, it was important as we looked at these modules that we didn't just throw away decades of organic knowledge in terms of how to configure network devices, how network teams interoperate with the rest of IT. It could not be a scenario where the network teams were suddenly faced with this daunting task of relearning how to operate their infrastructure. The way I kind of like to describe it is, we wanted to augment network operations, not simply replace it or do it a new way. So from that, we get this idea of really DevOps is all about, or Ansible is all about, DevOps meeting the CLI and starting to introduce the ideas of automation. We focused on three key areas as we started looking at how to do this. The first area was around that of configuration automation. And to be quite honest, right, if we didn't get this part right, the rest of it was mostly immaterial. If we can't, in a reliable, in a predictable, in a scalable, and in a repeatable way, push configuration changes out to network elements, the reality is the rest of it is completely immaterial. So that was really our starting point. From there, we started to introduce ideas around test-driven networking, and this is kind of a new and emerging area kind of in the networking field, and it's one that I'm very passionate and very excited about. The idea of test-driven networking is all around, or is all focused and based around this idea that it's not good enough to simply push configuration into a device. More so, it's not good enough to just confirm that the config that we think is on the device is actually there. It needs to be more, it needs to be more intelligent, it needs to be able to do more. And what I mean by that is we need to be able to take into account ephemeral state information and apply it to configuration management. We need to be able to, over the course of pushing changes, configuration changes into the network infrastructure, we need to be able to evaluate that not only are those configuration changes taking hold and actually are being configured on the device, but that the device is transitioning to a steady operating state that we expect. So let's kind of put that into a real world scenario. As we push out network config change for, say, building out an IP interface, we need to do things like first turn up the interface and make sure that the interface came operationally up. But we can't just stop there. We need to be able to look at various characteristics of that interface to make sure it's reached a steady operating state before we continue on with pushing out additional changes. So we have the ability to look at things like LLDP peers, or maybe TCAM entries in the MAC table, or route entries in the routing table, or whatever is important to you as an operator, as a network engineer, to ultimately satisfy the fact that you now know that you've reached a steady operating state before continuing on with your automation task. So we're going to show you how we did that today. We did it in a way that leverages the same things you know and love and the same tools you use today, effectively show commands on these devices. So we'll show that here in just a few moments. Last but not least, and I think the other key point of this is this idea of continuous compliance. Continuous compliance is all about, now that we understand what needs to be configured, now that we understand that what the ephemeral state is to ultimately confirm that we're in the right configuration state, we can now go back and we can test those configurations, and we can make sure that configuration changes that were pushed in today are still true next week, are still true next month, are still true next year, until we ultimately decide that they should no longer be true and we achieve a new state, whether that's decommission or config change or whatever the case may be. So these are really kind of the three pillars by which we wanted to start building network integration. Late last year, we announced that we were going to start going down this path. So on the right-hand side gives you an idea of today the current sets of platforms and operating systems that we're working with. All of these have been built directly into Ansible Core, so that there's no installing of any additional libraries, no installing of any additional components to ultimately work with these devices. This is true both for working with these devices over the CLI, via SSH, as well as working with the various APIs, and we will continue to expand this list as more and more networking vendors provide additional API capabilities for Ansible to start working with. In addition to that, we will also be expanding the list of devices and operating systems, as time goes on. As I mentioned very early on, this is very much the beginning of a journey, not the end of a work sprint. What we added, though, to the technology preview are the first sets of modules that utilize the network device support. And they really kind of fall into one of three categories. The first one being command modules. This is how we actually extract data out of a given network device. The second one is a config module, and the third one is a template module. We'll actually look at these in a little bit more detail as we move forward. So as we look at the command module, and that's really kind of the starting point of this journey, what you see here on this particular slide is an example of what a task would look like in an Ansible playbook that ultimately calls, in this case, I just arbitrarily chose the Arista EOS command module. Now, what you probably notice very quickly is that the commands, or the way that we extract ephemeral state data out of a given network device, is based on the same sets of show commands that you're already used to running on the device itself. So there's no having to learn, a new set of constructs, a new set of commands, a new set of anything to ultimately start the process of evaluating network state. Now, in this particular example, we actually can run two show commands. I could put a whole list of show commands that I want to run, and I simply just piped them through JSON. I didn't have to do that. It just made my life a little bit easier as we get to the next component, which is the wait for component. But we can run these commands, and we get the output back. We'll see this in operation here in just a moment. But the wait for is where it gets very interesting. Wait for is actually allows us to introspect the return from those commands, looking for key values and forcing them to meet a set of conditionals. If the commands never achieve that set of conditionals, so in this case, if Ethernet 1 never actually goes into a state of up and connected, this task will fail, and thus the whole play will fail. So we can start to look at the various pieces of the configuration as they're pushed onto the box and validate that the resources are achieving a given state that we're defining based on those show commands before we allow additional configuration to be pushed into the device. Now, I think this is key from the aspect that this should mimic and or mirror a lot of what you're already doing today, right? Most networking teams are doing this, either through homegrown scripts or they're doing it through manual processes. Simply what we're doing is we're providing a framework now, a foundation that allows you to automate it. The next example is our first config example, and what this does is, in this case, I actually took the Juniper Junos config module, and in this case, what we do is we actually can push lines of configuration into a device. Now, we don't just simply blindly push configuration into a device. I think we all agree and we all know that when you start just simply blindly pushing config into a device, that creates a bit of a problem for those constructs that ultimately would maybe rewrite firmware or create, even how slight could create interruptions in the data flow of traffic. So in this case, what we do and how these config modules work is they will ultimately attach to a node and they will evaluate the current running config of that node. It will then compare it against the desired set of configs that we've listed here in this particular config module, and it will only push in those commands that it sees as different or that are not correct, that we can, that need to be pushed in the box to ultimately bring it into a steady operating state. Now, for those of you new to the Ansible world, as you look at these lines, obviously you should probably recognize the set commands if you've done anything with Juniper. These are simple Juniper config commands, but the things in double brackets are simply variable substitutions. And we have ways then to be able to substitute variable values into these commands such that the playbooks themselves become very scalable, and we can start to separate the idea of what is the data model and what is the execution. Because I think, this is really the key to introducing network automation. I think for far too long, the networking industry, we've all been paralyzed around this idea of a networking data model. And that's not to say that it's not important and that we don't need it, but that we've become so consumed with the idea of a networking data model, that it's prevented the ability to create tools and allow tools like Ansible to start to build components around automation. By creating that nice clean separation here, you start to be able to manage your data model. And a data model could be whatever you define it as, whether it's IP addresses and VLAN IDs, or it's routing protocol policy, or it's access lists, or it's SNMP community strings, however you want to define your data model. Ansible really excels at taking your data model then and focusing on the execution of that data model by ultimately getting it into the box, with being able to pull away from having to deal with some of the intricacies of individual device implementations. I'll show you what I mean by that when we get into the demo of this. So this is an example of that same Junos playbook now run. And what I chose to do for this slide is I actually run it in what we call check mode or dry run mode. Check mode actually allows the play or the playbook to run without actually introducing a set of changes. So it effectively does everything it would have done, it just doesn't actually perform the configuration. Now you might be wondering, well, why bring this up? So one of the things that we focused on as we put this together, and we heard this again very loud and clear from a lot of the folks in the community that we talked with, is that stepping into automation needed to be done at different paces. Different organizations are going to adopt network automation at varying degrees of pace here. And so what we did with all of the modules that based on configuration is we produced this key called updates that you can see here on the screen. And effectively, what updates is doing is it's telling you what change it would have made on the end device. This allows you to get very comfortable working with Ansible in your environment and start to see how Ansible would have made a particular configuration change without having to take that leap of faith, hit the go button, and hope everything works out just fine. In this way, it allows you to start to work with it in your lab environments, and then ultimately work with it in your production environments, but maybe not necessarily turn it on just yet, and be able to put some manual process around it until you become more comfortable working with the changes that Ansible would have made on a given device. The last set of modules is the template modules. And in this case, I just arbitrarily, again, pulled Cisco NXOS template modules. Now, template modules work very similar to the config modules, but in this case, they actually work with the configuration file that you've known and loved for years and years and years. So in this case, and then the other thing I wanted to show here is how you could start to break up your configuration into chunks that make sense. So as we all know, right, network devices have always suffered from this idea that we have one config file and everything's kind of munged into that config file. But in reality, what is in that one big config file is a set of different application configuration settings. By utilizing Ansible, we now have the ability to break those things up into manageable applications that can be independently version controlled, that can be independently audited, that could even technically be independently managed by differing teams. So you could have folks that manage, say, the SNMP application on your network device, or you could have folks that manage the syslog device settings and no longer burden the networking teams with having to manage those things, but yet still feel comfortable with how those settings ultimately get pushed into the network device, because it's the playbook that does it, and it removes the need to know the underlying mechanics of how that ultimately happens. Now, templates themselves, as I promised you, look just like config. So here's an example of the interfaces.j2config. This should look very familiar, very comfortable. It's interface and a name, and then we indent by 2. Now, structure does matter here, and that's how these templates work, because the reality is that network device configurations have a structure to them. No, they're not quite as complex as XML or JSON or whatever your favorite markup language might be, but they nonetheless are syntactically, they follow a set of rules. And so templates, in this case, follow that set of rules, and that's how we're able to push a lot of these configurations out and ultimately determine what changes need to be pushed into a given device. So in the next configuration template, here you see we've pushed out the IP interface. And now after I pushed out the interface config, I could have gone to one of my commands plus wait for and wait for that interface to come up and achieve a steady state, and then go ahead and push in my IP configuration. And then I could again repeat the process of validating that I've achieved a steady state. Maybe it's doing a ping, maybe it's looking at a routing table entry, whatever it might be. And then I could continue on and write on through the rest of my playbook. As we went through this though, all of the development work that we do is based on running this against virtual machines in a development environment. So we've got all of the major platforms running in VMs, and that's mostly what we do our development work against. However, as someone who's worked in this industry long enough, I certainly know that there are specifics that are unique sometimes to hardware platforms or even images that you get from various vendor implementations. So one of the things that we did is we made a conscious decision to put all of our testing playbooks out in GitHub. The reason for that was really twofold. First and foremost was to allow the Ansible community, effectively everyone here, to contribute to those testing playbooks, to add additional test cases that either A, we didn't think about, or that may be unique, or that just simply should be there as good, solid test cases. But more importantly, the reason why we released all the testing playbooks in open source is so that you could pull them down into your own environments, so that you could test them against your hardware with your configurations, so that you didn't have to reinvent this wheel and you could get started much faster, ultimately automating your network infrastructure. The other kind of component to this is that because all the testing playbooks are out in the open source, is that every time someone adds any additional code to the networking modules, we then run it through all of our test playbooks so that it's being tested, so that as you, the community, gets more involved with Ansible modules and you offer up code changes, added features, brand new modules to the Ansible repos. Those actually ultimately then can be tested, against the same set of VMs that the Ansible core engineering team is testing their modules against. So a couple of random thoughts here, and then we'll get on to actually looking at some of this, which I'm sure is what most everyone is really looking forward to the most. The first one is I remember early on I talked about that Ansible playbook authoring had to be the same as it always has been. And nothing could be further than the truth than this first bullet. And this was maybe the one that I heard from so many in the community very loud and clear, and that, Ansible has a whole set of constructs around tasks that really add to the feature functionality. One of those is the idea of delegate to. And delegate to simply says, in the context of what we're doing here, go to a jump host and then execute the automation from that jump host so that you can create gated entry points into your network. This is a real key feature for those organizations that want very strict controls and very hard lines between what the backend automation system is doing and how it ultimately accesses your network. The next one is the use of command plus wait for, and we've touched on this quite a bit already, but it's that, ephemeral state checking has to be every bit as much in the discussion about automation as does configuration changes, because we're working with dynamic real-time systems. And I think we can all agree that, while it's wonderful to be able to push automated changes into the environment at a rapid pace, we can just as rapidly create a situation that creates entire network meltdown. So that we have to have a set of modules that introduce ephemeral state checking, and that's what the command module is all about. Now, the first set of modules are based on configuration commands. We'll look at them here in just a moment, but they were built in such a way that actually allows you to start to build roles on top of them. So ideally, we would have declarative config modules for every single feature, knob, widget that every device vendor out there supports in their CLI, but that's not reality, and it's going to take time to build all of those modules. So we can, at least where we have now, is we have the ability, though, to start to at least put some structured logic around these things in the ways of roles. And roles are just simply reusable units of code in the Ansible environment. And those roles can be shared both internally or externally through the Ansible Galaxy system. So we can start to do that. I'm going to show you that here in just a moment. So this is my last slide, I promise, and we will actually get to looking at some of this because that's where the excitement really comes. But, the last thing I want to leave you with is all about get involved. Networking is relatively new to this whole idea of open source movement. And the best thing I always tell folks in networking professionals in this industry is open source can be a great source for working with your peers, for personal achievement, for personal for expanding your skill sets, just simply getting involved to be able to do things, both take and receive, from the open source community. So, I would say that the first thing to do to get involved is attend today's webinar. Well, you've done that. So now you're involved. We're all involved now. So the next thing to do is go to releases.ansible.com and download the technology preview. Start playing with it in your environments. I would love to hear your feedback. I would love your pull requests even more. But, I'm a big advocate of, I can promise you that I didn't get everything right the first time. We didn't get everything right the first time. We will never get it all right the first time. We'll never always get it all right. But collectively as a community, if we all work towards building these sets of modules for automating network device, that's where the whole is significantly greater than the sum of the parts. And we can all collectively build network automation. So by that token, join the community. Ansible Project, Ansible Devil are our two main mailing lists. Get on them. Start listening to the chatter that's going on. Send your questions out there. I'm out there. I listen. I respond to them. Just simply get involved. Come on out to the IRC list. All the core development team is there. There's so much to learn about how Ansible works in general, and more specifically, how you can start to get involved from a networking standpoint, whether you want to write code or whether you want to do documentation or whether you want to present use cases. However you want to get involved in the Ansible networking community, we welcome you. It's just a matter of picking up your favorite IRC client and jumping on board. Okay, so let me get off slides. As I promised, I am an engineer. I am not a marketing guy. And let's actually start to look at some of this, because I think that's where the use cases really kind of start to come together. So the first one I'm going to show you here is actually not on that screen. It's actually on this one. So what I'm going to do is I'm going to simply show you what we're working with from a lab perspective. And I'm going to do it not by putting up a network diagram, because in a lot of respects, the links aren't going to matter for what we're doing today. But I am going to show you in terms of by collecting facts from utilizing Ansible. Let me make this just a bit bigger so we can all see what's going on here. Okay, so I'm going to run this facts playbook. Well, heck, let me just kind of get it started here. Make sure my VPN is still up. Yeah, it is. So we can see Ansible is going out there and running. And so what Ansible is doing right now is it's just simply going through a process of collecting fact information, from a various sets of devices here. Now, all of these are built into a role called Network Facts that I've created for this webinar. And I actually have put all of this code into my GitHub repo, so it's all shared with you. You're more than welcome to dig into it. It's not necessarily built to be a better set of best practices, but it's built to showcase a lot of the capabilities that Ansible can provide with doing things different ways, because there's no one right way or wrong way to do things. So you can see my playbook has finished running, and I'm going to scroll up here for just a moment. And you can see that what it's done is it's collected all this fact information. What it's returned to me is it's returned to me the name of every node in my Ansible development environment, what type of node it is, and then what version of software that it's running. So you can see here I'm running, in some cases, I'm running EOS with running 4.15.0F. I'm running Juniper VSR against VSRXs, running 15.1 code. We're running OpenSwitch, running 0.3.0 of the OpenSwitch code. We're running 6.0 and so on through the list. I won't read all of them, but you kind of get a sense of it. But the key here is because we're utilizing Ansible to do this, and because Ansible is running through this by a set of facts that it's gathering from the devices, we can start to normalize that information, right? And I think this is the real key point, is that because we utilize Ansible as a language for ultimately being able to do automation, we can start to normalize values that make sense in your environment. If you want to call an IP address, a horse, you're more than welcome to do so, because it's your environment. It's what makes sense to you and to your teams and to your operational environment. We can simply write playbooks that extract the right pieces of information and present it in a way that is key to how we do things. So I'm going to run another playbook here. This one is actually called git config. And you might guess what it actually does is it actually goes out and it's going to collect configuration from the same sets of nodes here. Now, it's going to do basically the same thing. It's going to collect a bunch of fact information. And one of the things that we collect with all the fact information is we actually collect the config. So, one of the things that's important as we look at networking and we look at changes in networking is it's important for us to always be able to grab that, copy of that config. Sure, we can always save it, to a startup, to a medium that will survive a reboot. But a lot of times we also want to be able to pull it off the box and store it in back-end systems. So what this did is it actually ran against all of my devices, and it actually produced for me, I won't scroll through all of it, but it produced for me show run. Now, if you've done nothing else, if you simply pull down this playbook that I've shared out on my GitHub site, github.com/privateip, if all you do is take this play, you already have something that's going to work in your environment that you can get a tremendous amount of use of, because you can now back up configuration from your devices. Now, in the Ansible world, one of the things that is quite nice about Ansible, because we utilize a push model instead of a pull model, we have the ability to single out either nodes or groups of nodes for doing operations. So in this case, what we're going to do is I'm actually going to run git config again, but this time I'm going to restrict this, and I'm going to restrict this by using a limit statement. I'm going to restrict this to, let's look at VSRX01. And I'm just going to supply the name of the host that I'm interested in. And by doing so, now Ansible will do everything it's always done, but instead of running it against my entire network, I can restrict it to an individual node, or I can just restrict it to a set of nodes. And you can see, sure enough, here it is. It's gone out and it's pulled out my configuration, and great. So now I have it. But extracting data is not what we're really all about, right? Really, we're all about wanting to automate configuration, in the network infrastructure. So the next play that I want to share with you is one that really emphasizes what I talk so much about, and that is bringing together the ephemeral state checking capability of Ansible along with its ability to perform configuration. So I'm going to switch over to a different terminal window. We'll talk through this in just a moment. Make that a little bit bigger. I'm going to show you what this playbook looks like. So what this playbook is going to do, it's actually going to run on one node. We can see it here, host NXOS03, Nexus 03 is the host in my environment. And what we're going to do is in the first task, we're actually going to force an interface to go down. You can see here that I'm telling it, I'm using the config module. I'm saying shut it down, interface Ethernet 210, and I'm going to force it. I'm not going to actually evaluate. I'm just going to simply force it down. And then I'm going to utilize a show command to collect some data. And what I'm going to do is I'm going to ultimately get down to, and I'm going to do a wait for, and I'm going to say, I don't want this play to continue until interface Ethernet 210 comes up. Now, of course, we know that we just shut it down, so it's not going to be admin up. But let's just go ahead and let's get this thing going, and we'll take a look at it. So we get our play started, and the first thing, as I mentioned, we do is we disable Ethernet 210. Let me go ahead and log into my box here. So if we look at Ethernet 210, we can see sure enough it's administratively disabled. But on the left-hand side, what you see Ansible has done is he said, wait a minute, it never came up in the time frame that I expected. And by default, we try it 10 times over 1 second intervals, so 10 seconds, and which is configurable in the task itself. But Ansible, in this case, said, you told me I had to wait for Ethernet 210 to come up. It never came up. I'm stopping right here. I'm doing nothing more. I'm not going to continue to push out any configuration. I'm not going to do anything other than fail. Now, using other Ansible constructs, we could have done a variety of things. We could have executed a different set of tasks. We could have wrapped this up into a block rescue construct in an Ansible playbook, and we could have undone the configuration. So I could have removed the configuration. So I can start to add elements of things like rollback capabilities built right into the playbook. Because in reality, right, rollback is nothing more than another procedure, another automated configuration procedure is ultimately what we want. It's not necessarily one feature, it's a number of things. So we can start to introduce those ideas, within the way we run playbooks. So let me go ahead and run this again. So we're going to go ahead and run the command, but this time I'm going to go in, I'm going to actually physically do a no shut on the interface. If I learn how to type. So I do a no shut, and you notice this time on the left-hand side that the interface came administratively up. So therefore, the play actually continued. And now it comes up and it says Ethernet 210 is administratively up. The playbook has completed successfully. There was no errors, and everything flows the way it always has. So now we can perform additional configuration. But I think the key here is if I cat this out, and again, you can see all of this in my GitHub repo if you really want to kind of take a fine-tooth comb over this code. But the key here is that we're simply using the same outputs, the same commands, the same constructs that you would have used if you were to do this manually. You would configure an interface, then you do a show interface on whatever your interface name is, and you would look at the output of that show command. What we've done is we've just simply provided a mechanism for automating it. Now you might recognize here, well, yeah, this is easy to do when we've got, a JSON RPC, or I'm sorry, a JSON API, structured JSON message back like we get from NX API or from eAPI in Arista's case, or piping it through display JSON in Juno's case or whatnot. But not every device supports that. You're right. I did it this way to simplify it a little bit because it just saves writing regular expressions. But the reality is we can do it for boxes that don't provide a structured output. Okay, so that's the config or the command. Now I want to shift gears a little bit. I want to talk a little bit about some of the config capabilities. And one of the things that I mentioned in the configuration capabilities was the fact that configuration is all about evaluating current state of the box and then trying to figure out what is the right thing to do. So what we're going to do here is we're actually going to build a playbook live as we're kind of sitting here. I'm going to switch over to a different directory here where I've got my environment ready to roll. Okay, looks good there. And what we're going to do is I'm going to log out of this box, and we're going to, I really do know how to type. We're going to log into one of my iOS boxes. So the reason I want to show this one, I think the reason this is important is the fact that, iOS doesn't give us an API. It actually is running over the CLI, and I'm going to show you how easy this is to actually start to introduce change. So if we do a quick look at the show running config here, what you're going to see, of course, is that hostname, we're just going to do something very simple here. Hostname is set to iOS. We're going to build a playbook that is going to change the hostname. And so what this hostname is going to do, I actually, to avoid having to type it all out, I just wanted to show it to you so you can see what it looks like. Although I did log into iOS 01, so I need to change that. Save that. So what this playbook does is simply going to change from hostname iOS 01 to hostname foo. Now, this playbook has a very particular relevance in this demonstration because, when you work in engineering and you write software and you do software-based demonstrations, you always have to have a demonstration that includes foo somewhere. So that's why we're going to set the hostname to foo in this particular case. So we're going to go ahead and we're going to run that. And let me go ahead but this time I'm going to add the check mode. Whoops. So that we can see what's happening without it actually affecting change. So as I promised you, it will come back and it'll say, hey, wait a minute, I need to change hostname to foo. But since I was running it in check mode, I can do a show run on my network device and see that my hostname is still set as iOS 01. It actually hasn't made a change, even though it knows it needs to. But since we're really interested in making real changes, let's get rid of check mode and let's run it one more time. So in this particular case, it's going to go through and it's going to say, this time I want you to actually make the change. You notice the additional key here responses, and a blank response simply says that the configuration took properly. And if I do a show run, we'll see that the hostname indeed was changed to foo. Now, the way that this works is it simply is introspecting the configuration from the node. It's looking to see what's different, and then from there, it's actually performing the configuration. Now, in the case of Ansible, I can run this playbook time and time and time and time again. And as you can see here, it's no longer telling me it needs to update anything because now it's set at hostname of foo, and therefore it doesn't need to make a change. Now, whether I had one config statement or 1,000 config statements, each one of them is done the same way. And there's various arguments in these modules that allow us to deal with sub-context config modes, interface config and ACLs and so forth. But effectively, it's all the same. And you just simply build out your playbooks and you get to, you can run them against your devices. Now, I want to switch to Tower for just a moment here and show you what this looks like from a Tower perspective. This is what you see when you first log into an Ansible Tower instance, a nice little dashboard of what's going on. But the job we're going to run here is a job that allows us to deploy SNMP on network devices. Now, one of the questions I get asked quite often is that we built a set of device-specific modules, and really what we want to be able to do is we want to be able to push config out that is independent of the actual device, and this is where roles come into play. So what I'm going to show you here is out my SNMP playbook so you get a sense of what it looks like. The SNMP playbook, let me get rid of the extraneous there. This is the SNMP playbook that we're about to run through Tower. Now, what you should notice very quickly here is that there is no mention of vendor anything here. What we've got is we've got a role called SNMP. We're going to put it in a state, and that state is going to be present. We're going to configure a contact and a location. We're going to set up some SNMP communities here, public and private and operations. And it's going to do this based on the device that it's connecting to, and it's going to invoke the right sets of configuration for that given device. Now, just to make this demo just a little bit more interesting, what we're going to do is I'm going to log into a box. We'll just choose VES03, and I'm going to go into config mode, and I'm going to do SNMP community. I think I am. SNMP community, test read only. Now, I know nobody out there ever puts test config into their box, but for those of you who have friends in the networking business that tend to want to put test config into a box, this is a great demo to show them. Because what we've done is we've created this test community because we were testing something, but say we forgot to go back and remove it later. We want to make sure that these roles can deal with these types of scenarios because we don't want rogue configuration in our boxes. So if I do a quick show and run, and I can see that I've got operations, I've got private, I got public, and I've got test in here. So I'm going to go ahead and run this, but this time we're going to run it actually through Ansible Tower, as I mentioned. So SNMP, and we're going to kick off the job. Now the first thing it's going to ask me, Thor, is it's actually going to prompt me what set of devices do I want to run this against. So one of the things that Ansible Tower has the ability to do is we can run jobs that are global to the system. Whoops, didn't mean to cancel that. We can run jobs that are global to the system that run against everything out there, or we can actually prompt an operator for various pieces of input that tells them what they want to run against. So I'm going to actually run this against all my EOS nodes. These are the choices that I have available to me. I'm going to launch that job, and that job's going to go out and it's going to start doing what it does. Now, as that's running, I'm going to open up the output from standard out as this thing is running, because what I want you to see is that Ansible Tower truly is wrapping around Ansible. So an investment in learning Ansible from a core engineering perspective is ultimately not changed when you move over to Ansible Tower, because Ansible Tower is really how you operationalize the solution. So you can actually see Ansible is actually running, and it's going off, and it's actually making a change. And the first thing it's doing is it's going out and it's collecting all my network facts. And then when it's done, it's actually going to, and you can see it down here in my task, it actually removed my test community from my VEUSO3 instance. So we get one change, and I can go ahead and verify that by relooking at my configuration. And I can see that sure enough, test is now gone. I have now stabilized my SNMP communities, thank goodness for that, so that the right set of communities are now configured in my device. So the way that we did this is that we built this role that is vendor agnostic, right? It allows us to run this against our environment and not worry about what the end device is. Now, someone had to build the role, of course, and these roles can be built by engineering teams, they can be built by operations teams, they can really be built by anybody who has working knowledge of how Ansible ultimately works. And the way that we do it is we've got a set of tasks here, and I will go into the tasks present. And you can see I've got an EOS task here, and here really is the set of tasks that ultimately get run. And we can see where it collects various pieces of information, it actually removed communities, and then ultimately applies at the end of this run, it applies a template to this environment. So if I go into templates, we can see here's the template that got applied. Now, you probably recognize in the double brackets, SNMP contact, SNMP location, these were all of the parameters that I passed in from the main playbook. But I think the important part here for networking teams that either A, have no desire to get into declarative config or module development or programming in any way, shape, or form, right? These are the same types of commands that you would have built for doing change management in your own environment. Okay. Last thing I'll leave you with is that Ansible Tower, as you saw, I had the ability to actually prompt an operator for a set of values that ultimately wanted to be applied to a given device. And the way that I did that, again, is something that I built. Everything we do in the Ansible world puts power back into the operations team, and it doesn't ever take the idea of just trust us in how it works. So here's my survey that actually was built that actually prompted for the question of what device grouping did I want it to run. As you remember, I had two choices, EOS and NXOS. If I wanted to add another choice, say iOS XR, I could simply do so. I could save that out. And then when I go to run this job, it will fail because I haven't built an XR SNMP role, or I haven't built XR into my role yet, but that's okay. What I want to show you is now it shows up, and now I could make this available to my operations teams. So the whole idea here, as you're looking at this, is that we've got tremendous amount of capability with Ansible Core and being able to build automation around network devices. The automation that we're building utilizes the same form factor, if you will, that you're already doing today. It's working with the config file. Now, there's a lot coming down the road yet in terms of building a set of declarative config modules that will allow us to even introduce more capabilities. But it's a great starting point for being able to automate and manage your environment. Longer term, as you get involved more in the Ansible community, there's an opportunity for us all to collectively figure out what are the right sets of modules and what are the right sets of abstractions, what are the right sets of components ultimately built into Ansible. So with that concludes mostly my demo. As I said, github.com/privateip, you'll find all these playbooks. Grab them, play with them, start beating them up, hit me on IRC, and give me your thoughts. With that, I'm going to turn it back over to Justin.
All right, Peter, thank you so much. Okay, we're 1 minute past the hour. We do have a number of questions, so we're going to try to plod through a couple of these really quickly. If we don't, for whatever reason, get to your question, it's something that we can certainly reach back out to you via email afterwards. But if you ask them in the little portal here, then we did capture them, and we'll be able to address them after the fact. So question number one, what is the plan for virtual or overlay networks such as VMware NSX?
Yeah, no, I think it's a great question. So I've got a very strong belief that as you start looking at automating network infrastructure, one of the things that I realized very early on is that, the idea of virtualized infrastructures, whether it's, interconnecting VMs, whether it's containerization or networking around containerization, as more and more functionality moves off physical or augments physical capabilities into the virtual world, that we had to have a baseline that allowed us to start solving those problems. So in order to constrict the problem domain, we made a conscious effort to focus on solving automation around physical network devices first. The belief being that if we get that right or semi-right, that the same contextual way of doing it will morph itself into the virtualized world, and it will make solving that problem much easier, because I think we can all agree that as we see the networking stack move into the virtualized infrastructure, it's going to be infinitely more complex and infinitely more difficult to deal with from an operational perspective.
Awesome. So next question is, can you do check mode in Cisco iOS?
Absolutely, you can do check mode, and you can do check mode in any of the modules. That is actually a feature that is provided by Ansible, and we're just simply tapping into it. Again, with all of the config modules, they're all built based on the same premise, and that is, if you run it with check mode, it will return to you the set of configuration commands it would have pushed onto the box.
Excellent, thank you. Next two questions are actually related, so I'm going to ask them as one. So first, what does the provider CLI evaluate to, or is that some key value always necessary for Ansible to work its magic? And then the second piece of that is, what does the CLI provider currently support in terms of additional vendors, i.e. Mellanox or others?
Great question. I was remiss in not showing you that. Let's actually go back to the terminal real quick, and I think this will make sense very, very fast. So what we're doing, and CLI is the way that I've chosen to name this. Let me bear with me here as I look at one that I want to show you here. We use the git config that we utilized earlier. I think it's in there. It is not. That's all right. We'll go into this one. We'll go back into our blocking one that we were looking at earlier. So in here, you notice you got provider CLI. Now I chose NXOS for a specific reason, because it also has an API. Provider is an argument that you supply to any set of tasks that ultimately pass in the credentials for how you log into the box. Now, CLI itself is just a variable name. Where it's actually picking that up is if I go into my inventory, you see that all my NXOS devices are in a group called NXOS. And we provide a variable for that group in NXOS, and it's actually right here. Now here's where I give away all my secret passwords, so bear with me. All you security guys out there, don't send me hate tweets. Essentially, in NXOS group, I actually have two variables defined, one called CLI, one called NX API. So that for any given task, I can switch between utilizing the CLI or the NX API by just simply switching the value that I provide to provider. They themselves, for those of you from a programming background, these are just simple, nested hierarchies, dictionaries in Python speak, right? That pass the set of credentials necessary to ultimately connect to an end device. So we actually have a set of modules for each of the operating systems that we support, going back to the slides, and more on the way. Excellent.
Next question is, you mentioned running a playbook up to the point where it actually fails and perhaps doing a block recover or a block rescue. But the follow-on question is, do the changes really up to that point remain up to the fail, or is there any kind of like log file analysis to validate that something actually was properly done before continuing?
Yeah, no, great question. In the answer to the question, unfortunately or fortunately, depending on where you come from, is it depends. And it really depends on what command failed and how it failed. So as we all know, and let's take into account here what we're actually doing. Let's set aside for a moment those platforms that provide a merge function already natively in them, right? Because I think we can talk about how those work, a little bit differently. But for those that don't, essentially what we're doing is we're effectively feeding those in one command at a time. So if the third command fails, that means command 1 and 2 took properly. And then the onus is up to the playbook author, the playbook designer, to ultimately reinspect through the rescue function within Ansible to understand kind of what is the new state of that end device and take the appropriate action. So again, it does depend, but that's essentially how it works.
Excellent. Next question, how does Ansible handle the elevated privilege escalation that's necessary to go between the run versus configuration mode on these devices?
Yeah, so there's actually two pieces to this. There is for those devices that support the quote unquote enable mode, essentially you have a set that could be added to the CLI commands, and I'll just show you what it looks like here real quick, without getting into too much detail here. But essentially we can do something that looks like this: authorize yes, and then auth_pass, my password. So essentially what those two keys would do is they would force the box to go into enable mode and then pass my password as the enable password. So that gets you into enable mode. The rest of it is actually handled by the shared module. And so it understands when am I going into config mode and when do I need to just simply be in executive mode to execute the commands or the config as necessary.
Awesome. And then, I've saved the best question for last, and that is, how can I contribute?
I am so glad someone asked that question. I think that, as I said earlier, open source is a tremendous community and a tremendous opportunity to get involved with. I think that the opportunity doesn't necessarily have to just simply be about writing code. We're trying to build a community around how we can better automate network devices and network infrastructure. So there's a tremendous number of opportunities, not only just in code development, but in writing roles, in working on documentation, or simply being an advocate on mailing lists at local meetups. We have, I think it's now north of 300 meetups worldwide that focus on Ansible. So there's lots of opportunity to get involved in the Ansible world. If you're interested in getting involved, by all means, and you're not sure where to get started, by all means, come find me on the IRC. Come, hit me on Twitter at privateip. Send me an email, spragata@ansible.com, and I'd be more than happy to have a longer conversation with you about how you can get involved in Ansible.
Awesome, thank you. And so that effectively wraps up our presentation today. What I'm doing is just launching a couple of quick polls to gather some feedback from the presentation today. Like I said, we have recorded this, and we will be making this recording available via email to the attendees, and it'll also, of course, be hosted on our website. So we've got a couple more polls that we're going to do here, but thank you so much for your response. Thank you for your time. And with that, we will share these polls and close out the rest of the presentation today. Thank you so much for attending.